So now we're going to take a look at some of the details of the TipCalculator class. So again, we have this class TipCalculator that extends activity, and each of our apps typically will have one or more activities associated with it. In this app, we have exactly one screen, so we have exactly one activity, as will be the case for some of our other apps as well, but we'll also introduce apps that have multiple activities. Now, within this TipCalculator app, we have a couple of private static final strings called bill total and custom percent, and we'll be using these with a mechanism that's provided for you by Android that enables you to have your app's state get saved when the configuration of the app changes, for example. So if I go over to my AVD for a moment, so we have our TipCalculator up and running here, and with the TipCalculator, the user might be interacting with it, and let's say, for example, they rotate the device. So I can do that by typing Control F11, and you can see that the device rotated, and as part of that, it reconfigured the graphical user interface. Now, it turns out it basically restarts the app from scratch when you do that, but yet notice the contents of my bill total field are still there, and all of the calculation values are still here, and my custom tip percent is still there as well. And the reason for that is when the configuration change happened, when I rotated the device, quote unquote, in this case the AVD, there's a method called onSaveInstanceState that got called, and in that method, which I overrode in this class, as we'll see in a later video, I'm actually saving the current bill total and custom tip percent values. Then, as the app is restarted, its onCreate method gets called, and I'm using those values, if they exist, to repopulate the bill total field and to reset the custom tip percentage as well. And by doing that, it gives the user a smooth experience in terms of ensuring that the app is still showing the state information that they had last entered in this case, or had last interacted with in some other app, and that way they don't have to sit there and re-enter the bill total just because they happen to have rotated the device. Another case might be where, say, a phone call comes in, and therefore the user temporarily leaves the app to go deal with the phone call and then comes back to the app. That's another case where the onSaveInstanceState can come in handy. And by the way, as long as I'm discussing this issue, it turns out that there's a so-called perspective available to you in Eclipse once you install the ADT plugin tools. It's called the DDMS perspective, and you can get to it if it's not already showing up as an item in the upper right corner here by clicking on this icon and clicking Other, and then selecting DDMS. I'm going to go ahead and click OK. And the DDMS perspective allows you to interact with the AVDs and the devices that you have connected to your computer. And one of the interesting things about it is you can simulate or emulate various state information, such as a call coming in or receiving an SMS message. So for example, if I wanted to send an SMS message to my emulator that's currently up and running, the AVD that you saw on the screen a moment ago, I can select that particular device in the devices list up here, and I don't have any other devices up here because right now I just have this one AVD executing. But notice down here that I have the ability to do things like interact with the device, and one of the things I can do is specify an incoming phone number. So let's just, for argument's sake, put all fives in there, and I can say that I want to simulate a call coming in or send an SMS message. So let's say I type hi there and hit an exclamation point. Now I'm going to just reconfigure my screen a bit here so you can see the message actually pop up in the AVD when I do this. All right, so again, I just entered this SMS message. Now I'm going to send the message and watch the status bar at the top of the AVD as I do that. In a moment, you see the message pop up. There's the phone number it came from and the message, and it also leaves this indicator here in saying that there's a message to look at in case the user happens to have missed it. Now, if I pull down on that, you can see it expands and covers up my app. So my app has actually been pushed into the background now. Of course, the user had entered in an actual bill total, and so I can see the message. Perhaps I decide to go reply to that message, which I can do by clicking on it here to go into the SMS app, or I could just say I want to clear that message. And when I do, it brings the app back up, and once again, I still see the bill total and I still see the custom tip percent. And again, the reason for that is the onSave instant state method got called to store that information, and then when the app came back into the foreground, it was able to redisplay that information because I had saved it. So that mechanism is all provided for you in the Android operating system. And now I'm going to switch back to my Java perspective here so I can see the source code once again. So as I mentioned, we'll be using these two constants to help us when we do store the bill total and custom tip percentages. And basically the reason we have these constants or these final strings is so that because we have to provide key value pairs for the items that we're storing when the app's onSave instant state method gets called. Now, in addition, we have a bunch of instance variables for this class, a double that represents the current bill total that you saw on the screen, an integer that represents the custom tip percentage, and then we have a bunch of edit texts and a text view. And the reason we have variables representing all of these different items, which, by the way, we've named exactly the same way as we did in our main.xml file. That's not a requirement, but of course if you're manipulating a particular component that has a certain name in the XML, it's probably a good idea to name the variable the same way just for consistency. But the reason we have all of these is because we will be programmatically interacting with all of these controls in the application. And in order to do that, we're going to have to link up, if you will, each of these variables to the particular control that it is going to represent, and we're going to do that in the next video inside of the onCreate method.